If you want to take it to the next level after prototyping and engage with more serious production, there are many different technologies available for fabric integrated electronics. Here we can see an overview on the different types of textile and fabric manufacturing and treatment. You would find embroidery, you would find sewing, weaving, nonwovens, knitting, spinning, breading, coating and laminating, printing, and chemical treatment. All of these come at different machine costs, material costs, and involve different process complexity. Of course, that affects the resistance to wear as well. For example, embroidery has high machinery costs typically, but low material costs. And then again, converting the patterns that you need to set up for an embroidery machine, making sure it stitches nicely without breaking the thread, involves quite a high level of process complexity. But the results are very resistant to wear. If you look at, for example, knitting, then the machinery costs are rather low, but the material costs are high. And again, it involves patterns and high process complexity with low resistance to wear. If we look at the production of conductive threads, spinning and treating, then there are three different types of technologies available. We can buy material that has an integrated metal wire around a polymer yarn, which you see on the top. We can coat it with metal, so the yarn is treated physically and chemically with a thin metal layer. Or we can use multiple metal multifilaments inside of the yarn, integrating metal fibers, which looks like this. So you would spin in metallic filaments into the base material, and that then provides conductivity. Conductivity with different resistance depending on the material used, so that affects the way you have to set up and power your smart garment. There are possibilities to make assembly easier by, for example, using fabric integrated grids, which also have different properties. We have seen that in the Levi's example. So by assembling a grid, you can sense, for example, where touch happens, but you can also use it to wire electronics inside of your fabric, effectively using the fabric as a PCB board. Yarns can also be used to create transistors. So one of the most important electronic components, where you have a gate that opens the connection to the drain. These types of technologies allow us to create things like the famous musical jacket created by Maggie Ort, A Piece of History, where you would use embroidery patterns to play a musical instrument. Conductive ink is a different technology. Conductive ink is printed using inkjet technology onto the fabrics themselves using multiple layers. That works the way it is depicted here. So step by step different layers are printed on. There is a removal process for excess color, and that allows you to create even more complicated electronics depending on what type of inks are being used. There are different conductive inks that are available in the market that can be used for that. For example, that's British technology here. You can print conductive trucks. So you have an encapsulation layer that then holds the conductive layer, and that can be used for example, medical applications such as in producing an EMG, or to produce a heater. This is another example by Young and others where a heating element is printed onto the fabric. This also allows to create more complicated components such as stretch and pressure sensors. Here an example of a pressure sensor that affects the way electricity is conducted in the fabric, and that can then be used to drive output, as you see in this example. Stretching changes the resistance of that stretch fabric layer, and that changes the way the lights light up. This can also be integrated in even more complicated garments, like here, for example, in a stretchable LED display printed directly on a textile. An example from the Holst Centre that allows integrating displays directly into the fabrics by printing. This also allows to create printable batteries. Imagine a handbag or a rucksack integrated with a battery that then can charge your phone. To do that, we have to run a process depicted here. We print a cathode first, then the electrolyte, then an anode, then the current collector, and that looks like this. This is an example from Kim and others. Mangan oxide, zinc battery. It also allows the creation of fabric PCBs. Well, they wouldn't be called breadboards really anymore, but fabric integrated circuits. Another technology that I already mentioned at the beginning is interactive embroidery. Embroidery using conductive threads to create user interface elements that can be reused in different types of garments. Here is a famous example from the Wearable Computing Center at Georgia Tech, where you see a potentiometer and a range of buttons that are activated by bridging circuits using the conductivity of the human skin, by using the conductivity of a finger, which is the same principle applied here in the JOGWHEEL. Different embroidery pattern for potentiometer, or a sequin array, or here knife-edged pleat, as they call it, which reacts differently depending on the direction you crush the pleat. When you brush over with your hand over the fabric, you connect the circuit in one or the other direction. These are several different production level technologies that you can use then once you have created the first prototype using Arduino to lift things to the next level and actually produce the garment, the smart textile, the e-textile that you have in mind at lower cost and higher volume.